This is Density, Transport, and Dynamical Systems, or How to Find a Buoy in the Ocean. We can consider a dynamical system to be a moving object and the thing that's making it move. Here's our buoy floating through the ocean. Because the buoy is small and doesn't have a large flat surface like a sail, we can ignore the wind and just consider the effects of the water moving the buoy. We'll assume that the buoy isn't anchored, so it can freely float wherever the water takes it. Now let's zoom out and look at the buoy from a different perspective. This is just a hypothetical buoy. It doesn't actually exist, so we can say it's located somewhere in the Atlantic Ocean. Because we're assuming that the buoy is moving with the water, we want to look at currents. We can model a current in a given location in the ocean with an arrow. If the buoy is located at the tail of the arrow, it will move with the current to the arrow's head. If there are lots of arrows representing the current in different places in the ocean, we can trace the path that the buoy would travel from its starting point. In reality, there are large-scale currents that can be modeled with mathematical equations. This particular current is called a double gyre. It isn't actually a model of current flows in the Atlantic Ocean, but we can pretend that there's some piece of ocean that behaves like this. We can call this collection of arrows a flow field. It shows the current's direction at any location. In a flow field like this, the thing that will govern the buoy's path is where it starts out. If it starts here, it will follow a path like this, but if it starts here, its path will look more like this. We can call this starting point in the flow field an object's initial position. Now let's say we have a satellite that takes a picture of the buoy's location. Because this satellite might be located hundreds or thousands of miles above the Earth, and the buoy, the Earth, and the satellite are all moving, this picture won't be perfectly clear. It might look more like this. This means that we don't know exactly where the buoy is located. It might be here, but it also might be here, here, or here. This is important because the buoy's initial position will determine where it winds up. What we can figure out is where the buoy is more or less likely to be located. We can draw a point at its center in the image and draw a circle around near where it looks like the image has completely faded. We can then make a graph of how likely the buoy is to be found at certain distances from the center point we marked. As we get further from the center point, we're less and less likely to find the buoy. Once we get to about where we drew the circle around the buoy, there's only a tiny chance of finding it. This can be modeled with a function called a Gaussian distribution. Instead of just looking at the probability of finding the buoy at a certain distance from the center, we can look at the probability of finding it at any point on the ocean's surface. That graph looks like this. The best way to look at the buoy according to this function is to look at a large number, say 100, of different possible locations or points. Because the buoy is more likely to be located at its image's center, these locations are more concentrated at that point and become less and less concentrated moving out from the center. We can call this a density. Because we know the mathematical rules that govern the current, we can look at how each possible starting location will travel through the ocean. This lets us know how likely different outcomes are. For example, only one point escapes to the left-hand gyre. This tells us that there's about a 1% chance of the buoy doing this. Looking at a point later in time, we can see that near the center point, points are more densely packed. This means that there's a higher chance of the buoy ending up here than elsewhere. If you were trying to find the buoy, you could look at this data more closely to see where you would have the best chance of finding it, and therefore where you should look. This same idea could be used to find a lost ship or debris from a plane crash. Last but not least, you can use the same idea to look at how a collection of objects would travel through a current. This can be applied to everything from a group of buoys to a trash spill to a plankton bloom.